So let's see how to build a RAG application by using LangChain, right? So we learned in the previous lecture that we have a total of 6 steps. The first one is preparing input document, right? So this is the data which is specific to your domain, that is your organization proprietary data, right? That is step number 1. And step number 2 is chunking the data. So we know each LLM has a context window size. So that is input plus output response together. Total number of tokens is nothing but the context window, right? So to avoid LLM context window size limitation, we are chunking our input document. And the next step number 3 is creating embeddings. Once we chunk the input document, the data will be in the text format. And we know LLM cannot understand text and LLMs can understand only numbers, right? That is the tokens. So that is the reason we are trying to create embeddings for the input document chunks. And the next step is storing those embeddings in the vector database. And similarity search means, let's assume when the user asks any question, the LLM will try to search in the vector database and it will try to retrieve the results. And we can also create a bunch of questions and create a RAG pipeline so the LLM can answer the questions, right? So now let's see these 6 steps in action by implementing a RAG application by using LangChain. All right. So first thing is, let's go to VS Code to set up the project. So I just opened VS Code, right, and it is all empty. So let me try to open a folder here. If you notice here in my C drive, I just created RAG demo folder. This is all empty folder. So let me open this folder from VS Code. So I'm in my C drive. So let me select RAG demo folder and select the folder. So let's try to create a new Python file, right? So select Python file and let's save it RAG demo. I'm saving as RAG demo, right? So we saved the file. So here we are trying to build a chatbot kind of application, right? Where we will ask a question and the LLM will try to predict the answers and retrieve the results, right? So the first thing is we need to pick the LLM so it can predict and answer any user question, right? So we have several options here and the universal option everyone picks is OpenAI, right? But we also have the cheaper solutions as well. We can go to Hugging Face. Like I said, Hugging Face is open source and it is free to use, right? So let me take you to Hugging Face. So this is the Hugging Face website and go here and click on models. So you can see we have 16 lakh models available, right? So these are all open source and free to use. So if you notice here, we can filter by task name, right? So we are trying to build a chatbot. So you can select question answer, right? Chatbot is nothing but question answering. So select question answering and you can see we have around 13,000 models available on Hugging Face. So you can pick any of these model. We have the sorting option here. We can sort by trending, we can sort by most likes, most downloads, recently created or recently updated, right? So depending on your requirement, you can come here and search by the task name and you can also sort by the different filters and then select the best model that you want, right? That is the step number 1, picking the right LLM, right? And not just Hugging Face, right? You can also use DeepSeek or Claude Anthropic or OpenAI, Grok, Olama. So we have several other models also, right? But if you have any specific application, you can come here to Hugging Face and search by the task and try to pick the trending models from here, right? For example, here we are selecting question answering models, right? For example, we have this DistillBert, right? So click on this. So you can see the model card, that is the model description. And if you notice here, we also have the code. You can use the below code to get started with the model, right? So click on this copy. So it will copy the entire code and you can make use of this model, right? So they are giving the sample code also, how to use the model, right? So from here, you will get the model description and the model code as well. But we will come to Hugging Face later. We have a separate section where we will go to each and every component of Hugging Face and we will deep dive, right? And like I said, we also have paid source. Either you can use OpenAI or Claude Anthropic, or you can also pick the model from Hugging Face, right? I will show both, right? So let's start with Claude Anthropic, right? So let's go to the Anthropic website and then try to get the API key from there. It is a paid source, right? Claude Anthropic is a paid source model. So let me show how to get the API key, right? So all you have to do is go to Google and type Anthropic API key and click on getting started. So if you notice here, we have Claude AI, right? So if you go to Claude AI, you will have to first log in, and then this is similar to your ChatGPT chat, right? So where you can go and ask any questions. We also have that option available here. So now first thing is we have to create an account. So click on account settings. So make sure you create an account. I've already created an account, right? So now in order to create an API key, we have to click on API keys. Before that, click on billing and make sure you recharge your account, right? So this is not that expensive. If you just recharge for just $5, it won't expire for a year. Just provide your credit card details here. Since this is confidential information, I'm not clicking billing and showing that section, but it is pretty straightforward. You can provide your account details and recharge here. So make sure you recharge by going to billing section, otherwise the key will not work, right? So once you recharged, you'll have to click on API keys. So here click on create key, and then here you can leave it as default workspace, and then let's give any name here. You can provide any name for your key. For example, let's give testing, and then click on add. So keep a record of the key below. You won't be able to view it again, right? So this is very, very important. Once you create a key, make sure you copy this key and save it in an environment file, right? Because once you lose it, you will not get the key again, right? So you have to create another key and then get the key again, right? So that is the reason. Make sure once you create a key, make sure you copy this key and save it in an environment file, right? So now let me copy this key, so we can save it in an environment file, right? So we can make use of this API key and make API calls, right? So this is our VS Code. In the folder rag demo, I'm trying to create a file .env. So this is the environment file, and here you have to give API underscore key and save the key that you got it from the Claude Anthropic website, right? So make sure you do not share this key with anybody, right? Because this is confidential and it is only for your use only, right? This key may not work for you because I'm going to delete this. So you are trying to save this Claude Anthropic API key in a secured place. So that is why we are creating an environment file and saving it here, right? And we will try to read this API key value from our code and try to use it, right? So now let's try to build our chatbot kind of RAG application by using LangChain, right? So first thing is we have to install the required packages, right? So let me provide all the packages that you need to install. So what you have to do, go to terminal, and from here you have to execute each command here. So pip install langchain and hit enter, and then pip install langchain text splitter, hit enter. Pip install langchain community, langchain anthropic, sentence transformer, and ChromaDB, right? So we need all these packages when we are trying to build a RAG application in our project, right? So either you can install one by one, or you can also just give in a single line, like pip install langchain, langchain text splitter, space langchain community, and space langchain anthropic, sentence transformers, and ChromaDB, and hit enter, right? Either you can do one by one or you can do all in one line also, right? So that is our first step. In my case, I've already installed all these, so I'm just trying to comment here. But for you, make sure you install all these packages. These are all the required modules in order to build our RAG application, right? So once you install all these packages, let's try to import all these packages so that we can make use of them in our code, right? So in order to import the packages, we have to use the import keyword, right? So we are trying to import. So because we already installed this package, so we are trying to import from LangChain text splitter. We're trying to import recursive character text splitter, and from LangChain community embeddings, we are trying to get Hugging Face embeddings, and community vectors stores, we are trying to get Chroma database, and from LangChain anthropic, we are trying to get chat anthropic, right? Because we will be chatting and we'll be asking a question and it will try to retrieve the results for us, right? We are using Claude Anthropic, and for chains we are using Retrieval QI. So do not worry about any of these imports. I will explain everything in detail, right? And this one is for reading the key from this environment file, right? So that is why we are using these two imports, right? So far what we did, we installed all the required packages and then we tried to import all the required packages so we can make use of them in our code, right? And before we deep dive into the 6 steps, first let's try to read the key that we stored in this environment file, right? So let's try to load environment variables from .env file, right? So how do you load it? You can use load underscore .env method, and then from there you can read the key. So how do you read the key? API key is equal to, you can give any variable name here, os.getEnv, this is the method, and here whatever name you have provided in the environment file, the key name, that is API underscore key, you have to give that name, right? And then we are trying to store it in this local variable, and then we are trying to assign it to the os.environment Anthropic API key. So this Anthropic API key is stored in this API key, right? So we are assigning this value to Anthropic API key, right? So down the line in our code, whenever we try to use Claude Anthropic LLM, we can use this API key and make the API calls, right? So far this is clear, right? So we installed the packages, and then we imported the packages, and then we read the API key, that is Claude Anthropic LLM API key. Now we already learned that there are total 6 steps, right? So the first step is preparing the input document. So that is step number 1. So let me try to give comments here. So all we are doing is just trying to print step 1, preparing our document. Print 50 times. This hyphen will be printed underneath this preparing our document, right? Now, just for our understanding, I am taking this sample content as an input document. This is just a dummy document here, right? But you can replace this content with any real-time data that you have that is specific to your domain data, right? Maybe you can store this content in a PDF file or any Word document or somewhere else, right? Wherever your domain specific data is present, right? So you can try to read that data and store it in a variable, right? So for now, I'm just placing our input document content here. This is just a dummy document, so I can explain the concept, right? Now our document content is stored in this document variable. Now let's try to print the number of characters that we have inside this document variable, right? So document loaded, length is equal to, we are using length function, and I'm passing the document variable here. So this will give us how many number of characters we have inside this document variable, right? And now let's try to see the preview of the document. So I'm just printing preview of the document, and we are only reading from the document variable first 200 characters, right? So this is our step number 1, right? So what we did in step number 1, we prepared our input document, right? So these are just the print statements. When I run the code, then you can see these in the terminal, right? So we just stored our input document here, but later you can replace this document with your domain specific data, right? So here we are trying to print how many number of characters we have in this document variable, this entire content, and then we are trying to just preview the document first 200 characters, right? So with this, our step number 1 is done. We prepared our input document and we stored inside a variable called document, right? And then you know that step number 2 is chunking this input document, right? So let's create step number 2, text chunking. And let me add these print statements. That is step number 2, chunking the document. So we are just trying to print 50 times hyphen, right? So underneath chunking the document, it will just print 50 times hyphen. When I run the code, then you can see in the terminal, right? So in order to split our input document, we have already imported text splitter, right? Recursive character text splitter. So let's try to use this recursive character text splitter and then split our input document, right? So this is how you can divide our input document. This is our recursive character text splitter. Chunk size is equal to 200, chunk overlap 50, length function is equal to len. We already calculated the length of the document, and the separators are 2 new lines or 1 new line or period or space. I will explain everything in detail, right? And then once you do the splitting, then we will get the chunks. We are using inside text splitter, we have split underscore text method, and we have to pass our document, and we want to chunk this document based on these parameters, right? And then you got all the chunks. Now let's try to print the chunks here. Document has been split into, here we got the chunks. Len of chunks means how many chunks we have created, example chunks, and then for each chunk, let's see if you get 3 chunks, this will loop 3 times. For each chunk, we are trying to print the corresponding chunk here. So number 1, what is the chunk? 2, what is the chunk? 3, what is the chunk, right? So that is how we are trying to get the chunks. So what we did in this step, we are using recursive character text splitter, and we are trying to chunk our input document by dividing the whole document into chunks, right? So that is our intent. And don't worry about these chunking styles. We have around 10 to 15 chunking styles we need to learn, and we have a separate section for chunking styles. We will deep dive into each and every chunking technique in detail, right? But for now, just remember, you can use one of the chunking style, that is recursive character text splitter, and the parameters are chunk size, chunk overlap, length function, and separators, right? So these chunks will define the accuracy of our model, right? The way we split the data is very important. If the data is chunked properly, then it will find the relevancy properly in order to do the RAG search, right? So let's assume the application that you built, right, the RAG application by using LangChain, if it is hallucinating, that means it is not predicting the accurate results, then what could be their cause? One of the reason could be splitting of the documents into chunks, right? Then you need to change the chunking methods accordingly, right? In case if your LLM is hallucinating, that means it is not predicting the accurate results, then you can come here and see whether this is chunking properly or not, right? Accordingly, you have to change these parameters. All these values are not fixed. These are all hyper-tuned parameters, right? So you can tune these parameter values according to your input document, according to your business need, right? And what are these parameters? For example, assume your entire document text is converted into embeddings, and assume we have a total of 500 tokens, right? So let me just explain here. We have a total of 500 tokens, right? So this is total number of tokens, 500. Now assume every 200 tokens are divided into one chunk, right? Because we gave chunk size as 200. So our total is 500. We want to divide each chunk as 200. So in chunk number 1, it will divide from 1 to 200. And in chunk number 2, it will divide from 200 to 400, because our chunk size is 200, right? So 200 plus 200 is 400. And in chunk number 3, it will divide from 400 to 500, because our total size is 500. But if you notice here, we also have chunk overlap, that is 50. So that means it will try to take these last 50 tokens from each chunk, right? So that means the first one is 1 to 200, and the next one will not start from 200, right? It will also take 50. We are trying to overlap 50 here. So that means it will be 150 to 350. 150 plus our chunk size is 200. 150 plus 200 is 350. And then again, it will not start from 400. It will try to take last 50 from 350, which is 300. And then add 200, it will be 500. So how did it divide? By chunk size, 1 to 200, 150 to 350, 300 to 500. So it divided the whole 500 tokens into 3 chunks, right? Chunk 1, chunk 2, and chunk 3. So why are we doing this overlap 50? This is around 20% of your input data tokens, right? We are doing this to preserve the context, right? To maintain the continuity of the document, we are overlapping the chunks. So the LLM will try to preserve the context, and it will try to understand the context of the whole input document. Here we have around 10 to 15 lines of input document, right? But in real time, you might have gigabytes or petabytes of data, right? So the LLM need to understand the context of entire document when we divided this document into chunks, right? So that is the reason we are giving this overlap, right? And all these chunks belong to the same input document, right? And the chunk size and chunk overlap, these are user defined parameters, and these values depend on your input data, right? So depending on your input document, you need to define these parameters, the chunk size and chunk overlap. And you also have to pick these values by trial and error, right? You try to tune these parameters and try to run the code and see if the LLM is predicting the accurate results or not. So you just have to pick these values by trial and error, right? And we also have the length function. So here we are giving the total length of our input document, right? And then the separators, these separators tells where do you want to chunk the data, right? Whenever you see 2 new lines, or whenever you see 1 new line, or period, or space. Whenever you see any of these, then try to chunk them. So the whole objective is to divide the data into chunks. And to maintain the continuity of the document, we are using chunk overlap, right? So I hope this is clear, the chunking of the input document. Here we are using recursive character text splitter, and this is from LangChain, right? So this recursive character text splitter, right, we have a function inside it that is split text. So this function helped us to chunk the document which is from LangChain, right? And also one other thing is, always make sure you try to use the latest version of LangChain, right? Because we don't have backward compatibility, always try to pick the latest version from LangChain, right? So with this we created chunks, and these chunks are in text format, right? So once we run the code, you will see all these chunks are in the text format. But you already know LLM cannot understand text, and LLM can understand only numbers. So what is the next step? Step number 3 is we need to convert these text chunks into embeddings, so the LLM can understand these embeddings, right? So the step number 3 is initialize embeddings. So I'm just trying to print step 3, creating embeddings, and I'm trying to print 50 times hyphen, right? Now we need to pick a model that can create embeddings for our chunks, right? So what kind of model to use for embedding? We have different options available, like you can pick any model from Hugging Face or OpenAI or any other model, right? For now, let's use Hugging Face because it is open source and free to use, right? So we are using a model that is sentence transformers. So this is the model that we are using from Hugging Face, right? This is a small model because our input is very small, right? So depending on your input, you have to pick a model that can create embeddings, right? We are using Hugging Face because Claude Anthropic doesn't provide embeddings, right? So that is why we picked a model from Hugging Face. Now with this, let me just try to print the model that is loaded. Embedding model loaded. It is embeddings.model name. So that will print this model name. And what will this model do? This will convert our text chunks into numerical vectors, right? So let's say instead of Hugging Face, if you want to use OpenAI, what you have to do, the first thing is you have to go to the OpenAI website, create an account, get the API key. Just like how I've shown how to get the API key from Claude Anthropic, you do the same way for OpenAI. And once you get the OpenAI key and pick the right model, then if you want to create embeddings by using OpenAI model, then you can use this code. What I'm doing here, embeddings is equal to, instead of Hugging Face embeddings, we are using OpenAI embeddings, right? And inside this, you have to provide the model name, just like how we did here for Hugging Face, right? So with this, we created embeddings, right? So we converted our text chunks into embeddings, that is numerical vectors, right? So that is step number 3. And next step is we need to store these embeddings, right? So here, in order to store these embeddings, either you can use your local storage or cloud storage, or you can use simple Postgres server to any other hi-fi servers like Pinecone vector databases, right? We have a separate section to discuss different vector databases that you can use to store these embeddings, right? I will discuss in detail in the next section, but for now, let's use one of the vector database, which is nothing but Chroma database, right? So what is our next step? We are trying to create and populate vector store, right? So how do we create the vector store? We are using one of the vector store, that is Chroma database, right? So what we are trying to do here is we are trying to create a vector store, which is nothing but Chroma database. So where did we get this package from? If you go up, you can see this, we got it from LangChain community vector stores, right? So now you understand the importance of LangChain, right? All the methods are available easily inside LangChain in order to build a RAG application, right? So that is why we are using LangChain to build a RAG application. So we imported this Chroma from LangChain community vector stores, and we are using inside our code to create vector stores. And inside Chroma, we have from_text method. So for this, you have to pass these 3 parameters. The first one is texts. For text, you have to pass these chunks. We already created the chunks in step number 2, right? These chunks. And for embeddings, we already created the embeddings in step number 3, right? So these embeddings we are passing here. And the persist directory is chroma_db. Dot slash means this is the present working directory, right? So here. So once you run the code, it will create inside this rag demo with a file named chroma_db. When I run the code, then you will see this chroma_db will be created inside this rag demo folder, where all our embeddings will be stored inside this chroma database, right? Now once you create it, let's try to print. So we can see in the console, vector store created with the following details. What are we trying to print here? Number of texts, right? So we passed chunks which we got from step number 2. We are trying to get the length of the chunks. And embedding dimension, we got the embeddings from step number 3. We are trying to get the length of embeddings by using the method embed_query, and then we are trying to print database location, which is nothing but chroma_db, right? So we are done with our step number 4. So what we did so far, in step number 1 we created the input document, and in step number 2 we created the chunks. We divided our input document into chunks, and in step number 3 we created the embeddings for all our chunks, and in step number 4 we passed the chunks from step number 2, embeddings from step number 3, and we created a chroma database and stored all our embeddings inside it, right? And what is the next step? The user will ask a question, and if it is present inside this input document, the model will try to retrieve the results for us, right? So that is step number 5, which is nothing but similarity search, right? So let's try to print testing similarity search, and we are just trying to print 50 times, just hyphen underneath this testing similarity search, right? And let's try to see our input document here. So this is our input document content. So we have about artificial intelligence, NLP, computer vision, and reinforcement learning, right? So let's try to ask a question about reinforcement learning, right? So let's just ask a simple question. What is reinforcement learning here? The question that the user will be asking is, this is a question answer, right? So we are trying to ask a question so that the model will try to retrieve the results for us, right? So let's store the results inside results variable. So inside our vector store, we have a function called similarity search, where you have to pass the user query and k is equal to 2, right? K is equal to 2 means this is a user defined parameter again. So here you have to define these value based on your input document, right? For your understanding, I'm just giving only 2, right? So what we are trying to do here, we asked a question. What will happen? LLM cannot understand this text, right? So what will happen? This query will be again converted into embeddings, and this embeddings will be searched inside the chroma database, because this one already has embeddings, right? We already stored our embeddings inside this chroma database. So our input query will be converted into embeddings, and it will be searched inside our chroma database, and then it will try to retrieve the relevant information to the user, right? So like I said, this index value k is equal to 2. This is a user defined parameter. So what it will do, it will search all the chunks, and it will try to retrieve wherever this question, what is reinforcement learning, is present. It will try to retrieve the top 2 chunks, right? If you give k is equal to 3, it will try to retrieve the top 3 chunks, right? So for now, let's just give 2. That way it will try to retrieve the top 2 chunks. From there, it will go and retrieve the results for what is reinforcement learning, right? Now let's try to print both the query and also the result, right? Because we gave k is equal to 2, so we will get 2 results, right? So let's loop in this results variable and try to print each result, right? So what is our query? Query is stored inside this query variable. So let's try to print most relevant chunks, right? Because we gave k is equal to 2, so it will give us top 2 most relevant chunks. Let's say if you have 10 chunks, wherever this context is relevant, right? So that is where it is trying to get us the top 2 most relevant chunks. So we have to loop this results variable to get the top 2 results, right? So what we are trying to do here, for each result, right, I comma doc. So I is the index, that is result 1, result 2, and what is the content, right? So with this step, we asked a question and the model will try to get us the top 2, because we gave k is equal to 2, the top 2 most relevant chunks for us. With this we get the answers from our model, right? And what is step number 6? We have to set up the RAG pipeline, right? So let's try to use Claude Anthropic and try to set up a RAG pipeline, right? So that is our step number 6. So I'm just trying to print step 6, setting up RAG pipeline, and I am printing 50 times hyphen, right? So how do we set up RAG pipeline here? Here we are trying to use Anthropic Claude model with the provided key, right? Because we already retrieved the key and we stored inside Anthropic API key, right? So make use of this and try to make an API call, right? So if you go back to the top, we already installed this package LangChain Anthropic. From LangChain Anthropic we are trying to import Chat Anthropic, right? So let's try to use this Chat Anthropic. This is for question answer, right? So that is why we are using the Chat Anthropic. So let's try to initialize the LLM with Chat Anthropic with Anthropic Claude, right? So we are using Chat Anthropic and the model that I'm picking is Claude 3.5 Sonnet 2024-620 and the temperature is 0.5. So these are the parameters to the Chat Anthropic. So with this we initialized our LLM, right? And instead of Anthropic Claude, since this is paid tool, you can also use other tools also. For example, let's say if you want to use OpenAI model instead of Claude Anthropic, so you have to first get the API key, and inside this OS environment variable, if the key is from OpenAI API key, right, here we are giving Anthropic API key. Instead of that, you can get the key from OpenAI and stored inside OS environment. Here you store OpenAI API key instead of Anthropic API key, right? And let's assume if the key is from OpenAI API key, then initialize OpenAI LLM by passing these two values to these parameters. Model name, you can use any model, GPT-4 or GPT-3, 3.5, whatever, right? And the temperature is equal to 0.5. So instead of Anthropic Claude model, you can also initialize OpenAI model, but make sure you get the key before you make the call, right? So both Claude Anthropic and OpenAI, these two are paid source models, right? For example, let's say instead of using these paid models, you want to use a open source model, right? You can also pull a model from Hugging Face, right? So let me show the code for Hugging Face also. So here make sure you get the key, right? Hugging Face hub. So this Hugging Face hub, this is just like GitHub, right? Where you will get a ton of models from here. So for example, here we are using Google Flan T5 small model, right? So this is a paid model, this is a paid model, and this is open source, right? Make sure you first get the key and then use the model, right? So these are the steps to initialize the LLM, right? Once you initialize the LLM, next step is we have to set up this RAG pipeline, right? So how do you set up the RAG pipeline? So inside this retrieval QA, which again we imported from LangChain chains, right? So that is what we are trying to use in order to create RAG pipeline. And inside retrieval QA, we have from chain type, and we have to pass these three parameters. The first one is LLM. LLM we already initialized here, which is nothing but Claude Anthropic. And the next thing is chain type is stuff, and retriever is equal to vector store, which we have already got from step number 4, right? We have already created this vector store. So inside vector store we have as underscore retriever method. So pass this, so you will get the retriever, right? So like I said, we have different methods available inside LangChain. So if you use LangChain, building RAG application is very easy, right? Because we have so many built-in functions available inside LangChain, right? So now you understood why LangChain is very important, right? Now with this we created our RAG pipeline. So now our pipeline is ready. Let's ask some questions, right? So let's say we are trying to ask these questions. What is reinforcement learning and how does it work? What are the main applications of computer vision? How is NLP used in real world applications? Because if you see our input document here, we are talking about artificial intelligence, NLP, computer vision, and reinforcement learning, right? So our questions are relevant to our input document, right? And now with this we saved all our questions inside questions list. Now by using this QA chain, that is question answer chain, get the answers, right, by using Claude Anthropic model, right? So let me try to print asking questions to our RAG system. So this is our RAG pipeline. So let's ask questions to that. So we have 3 questions, right? So for each question, let's try to invoke the method and then get answers. That is question 1, what is the answer? Question 2, what is the answer? Question 3, what is the answer, right? So let's loop in, right? For each question, let's try to print the question, and then here what we are trying to do, this is our RAG pipeline, right? QA chain, and we are using invoke method, and we are passing each question, right? So first time this question will be passed here, and then in the second time this question will be passed, and in the third loop this question will be passed. And what we are trying to do, we are trying to get the answer from it, and for that we are using invoke function, right? And if you want to know details about this, you can go to LangChain documentation and then try to read and get the complete documentation from there, right? So with this we asked the question to the RAG pipeline that we created, and we got the answers. So total 3 questions, so we should get 3 answers, right? So with the chains we are able to create this RAG pipeline, right? So like I said before, inside LangChain we have different components, and these chains is one of them, right? So we will talk about models, that is what model to pick and what tool to use, and what is the memory, and what are the agents, and what are the chains, right? So that is why chains are very important when we are trying to create a RAG pipeline, right? So what we are doing here, we are using retrieval QA from chain type, and we are passing these 3 parameters: LLM, chain type, and retriever. So LLM is the model that we are using. Here we are using Claude Anthropic, which we defined here. And chain type is stuff, right? We have different chains available. So we will deep dive into chains in the coming lecture. But the objective of this retrieval QA chain is it will go to the vector store, search for the user query, that is these questions. And again, you know, this is in the text format, the LLM cannot understand. So this questions also again will be converted into embeddings, right? Because LLM can only understand numbers, not text, and then it will try to retrieve the response for us, right? These answers. So let me save this code. So this is all about building a RAG application. Let's quickly go through the code. So what we did here, first we installed all the packages, and then we try to import all the packages so we can make use of these in the code. And here we are trying to load the environment variables where we saved our Claude Anthropic key, and then we are trying to retrieve it and store it here so we can use in our code. And then the step number 1 is we prepared our input document here, and we calculated our length of the document, how many characters are there, and we are just trying to get the preview of the document, first 200 characters. Here, instead of hard coding the text, you can also read it from any of your input document, right? Let's say if you save your input document somewhere inside your PDF file or Word document or somewhere, right? You can read it and replace here and store it inside document variable. And then step number 2, we are trying to chunk our input document. You know why we are chunking? Because of the context window limitation for each LLM, right? And to chunk we are using recursive character text splitter, and inside this we have split underscore text. We are passing our input document, and it will chunk by chunk size is 200, chunk overlap 50, and length is, we already calculated the length. So that is how we are able to chunk our input document. And the next step is these chunks are in text format, right? And LLM cannot understand text, so that is why we are trying to create embeddings. And here we are using an open source model from Hugging Face, which is sentence transformers. This is the open source embedding model that we are using, and with this it will create embeddings, right? In case if you want to use OpenAI embeddings, this is how you have to use. Here you have to pass the model name just like how we did here. Pass the OpenAI model, and then you should be able to use embeddings from OpenAI model. And then the step number 4 is once we create those embeddings in step number 3, we have to store them in a vector database. Here we are using Chroma database, right? For this we have three parameters. The first one is text, that is chunks, which we did in step number 2, embeddings, which we got from step number 3, and we are creating Chroma database. This will be stored inside our present working directory, right? So once I run the code, then you will see the Chroma database will be created here, right? And now step number 5, what we are doing, user is asking a question, right? What is reinforcement learning? And then it will go and search inside this vector store, and it will try to give us the top 2 most relevant chunks, because we gave the index parameter as 2. And then the step number 6 is we are trying to set up RAG with Claude Anthropic, right? So first thing is we initialized the LLM with Anthropic Claude, right? So the model name is this, and the temperature is 0.5. With this we initialized our LLM. Instead of Claude Anthropic, you can also use OpenAI. Both Claude Anthropic and OpenAI, these two are paid models, and if you want to use Hugging Face model also, this is how you have to use. But make sure before you use anything, you have to first get the API key, right? And then once we initialized our LLM, the next step is we have to create the RAG pipeline, right? Here we are using chain type, that is retrieval QA. Inside that we have from chain type, and we have to pass these 3 parameters. LLM, whatever we initialized before, that is Claude Anthropic, and chain type is stuff, and retriever is equal to inside our vector store, which we created in step number 4. So, right, inside that vector store we have as retriever. So call this method, then we'll get the retriever. And if you want to deep dive into all these methods, right, you can go to LangChain. We have a very good documentation inside LangChain website, right? So you can go and just search for these methods, so you can deep dive into these methods, right? And then once we created our pipeline, the next thing is we are preparing the questions here. So we stored all our questions inside a list, and then we are asking the questions. For each question, here we are trying to loop in, and for each question we are using this RAG pipeline and calling the invoke method by passing each question, and then we will get the answer. For each question, what is the answer, right? So we asked 3 questions, so we should get 3 answers, right? So that's the overall code to build RAG application by using LangChain, right? So once you have the code ready, now let's try to run this and see the output, right? So you can go here, run, you can try to debug, or you can also run without debugging, right? Or you can click here also, run Python file, if you notice here, right? So let's click run Python file. So it is invoking and trying to execute the code for us. It will take time because it needs to create the embeddings and retrieve the results, right? Okay, so it completed, right? So now let's deep dive into this output, right? So this is our step number 1. What it is trying to print, step number 1, preparing our input document, and we are trying to print this -50 times, right? And then the next things we are trying to print document length, right? It is total 944 characters. We are using len function and passing our document, and it is giving 944 characters, and we are just trying to get preview of the document first 200 characters, right? So this step number 1 is clear. And then the step number 2, chunking the document, right? So we are trying to chunk our input document, and this document has been split into how many chunks? Total 7 chunks. And the example chunks are, we are trying to loop in each chunk and trying to print it. Chunk 1, this one, and chunk 2, chunk 3, chunk 4, chunk 5, and chunk 6, chunk 7. So our total input document has been divided into 7 chunks, right? And why do you think we got 7 chunks even though we gave the chunk size as 200? Because of these separators, right? So whenever it says 2 new lines or 1 new line or period or space, right, it will try to chunk even though the chunk size is less than 200, right? If you see this here, it is not 200, right? Because if you see our document here, after this we have new line, right? So that is why it divided into another chunk here, right? And after programming we have period here, right? So that is why it chunked here. So because of the separators, even though we provided the chunk size, whenever it sees the separators, even though if it is less than 200, it will try to chunk it. That is the reason why we got 7 chunks, right? And here we have special characters, right? But instead of our special characters, you can use different other separators too, like paragraph or page or hash, because markdown means headings are written as hash, right, in Jupyter Notebook, correct? So instead of that, you can use different separators also here. So it all depends on your input data, right? So according to your input document, you have to provide the separators. So based on the separators, it will try to chunk our input document, right? So with step number 2, we created the chunks, and the next step is creating embeddings. So let's go to step number 3, that is creating embeddings. And to create embeddings, we are using Hugging Face embeddings sentence transformer model, right? So here it created the embeddings, and the model loaded is this one, and this model will convert text chunks into numerical vectors, right? And you can also use OpenAI embedding model also. And then step number 4 is, once we create the embeddings in step number 3, we have to store them inside the vector database, right? So what we did here, we're trying to print this and number of text, because we have a total 7 chunks, right? That is what we are trying to print here, length of chunks, total 7 chunks. So number of text 7, and embedding dimension is 384, and database location is Chroma DB, right? So this is where we have our embedding stored inside this Chroma DB, right? So if you go here, this was not created before, right? So now we got all the embedding stored inside this Chroma DB, right? So step number 4 is clear. Now step number 5, similarity search example, right? So we are asking a question, what is reinforcement learning? And we want to print the top 2 most relevant chunks out of these 7, right? So we asked what is reinforcement learning, and it is trying to print top 2 most relevant chunks. The result 1 is reinforcement learning is a type of machine learning where agents learn by interacting with an environment. They receive rewards for good actions and penalties for bad ones. So that is number 1. This is the most relevant chunk related to the question, what is reinforcement learning? And the second one is artificial intelligence AI is transforming the way we live and work. Machine learning, a subset of AI, enables computers to learn from data without explicit programming, right? So these are the top 2 chunks that it picked, and it retrieved those 2 chunks, right? And then the next step, step number 6, is we are trying to set up the RAG pipeline. First, what we did, we initialized our LLM. Here we are using Anthropic Claude. Instead of Anthropic Claude, you can also use OpenAI, or you can also pick a open source model from Hugging Face, right? And here we are trying to create the RAG pipeline, and we are using retrieval QA. This is one of the chain type, and here we stored our sample questions inside a list, and for each question, this is the list we are trying to loop in, and for each question we are trying to get the answer, and inside this chain we are calling the invoke method by passing the question, so we will get the answer, right? So what is the first question, what is reinforcement learning and how does it work? So that is question, and what is the corresponding answer, right? So where is this answer coming from? So it is trying to read the embeddings that we stored inside our vector database for all this input document, right? Now let me go back to these questions. So for question number 2, what are the main applications of computer vision? And this is the answer. And the question number 3 is, how is NLP used in real world applications? That is question number 3, and this is the answer, right? So with this, you understood all the 6 steps. That is, before going to the steps, first how to get the keys, right? The API key, and how to prepare your input document, and then creating the chunks, and then creating embeddings, and then storing them in a vector database, and then asking a question, creating a RAG pipeline, and ask the question, so you will get the answer, right? This is kind of a question answer system, which is nothing but a chatbot, right? So now with this, you understood why we are using LangChain in order to build a RAG application, right? Because we have a lot of built-in functions available inside LangChain, so it will be easy for us to build a RAG application, right? And majority of the generative AI applications are built by using this LangChain and RAG, right? With this, I hope you got a clear understanding on how to build a RAG application by using LangChain, right? And next, we have different other components inside LangChain, like I said before. We have prompt engineering, that is how to ask a right question and get the right answer, which is nothing but prompt engineering. And we have different chunking techniques available. Here we used recursive character text splitter, right? So similar to recursive character text splitter, we have different other chunking techniques available, which we will deep dive in the next section. And we also have other vector databases. Instead of ChromaDB, we have other vector databases too. We will deep dive into that. And chains also, we have different chains available. This is one of the chain. And the other topics are how to use different tools and agents and memory, and how to do the search technique and query expansion, that is to generate multiple queries so LLM can answer, right? Not just one question, that is multiple question. And how to evaluate the results that we get from the LLM, right? So once you know all other components, that is prompt engineering, chains, tools, agents and everything, then you will be able to build a end-to-end generative AI application, right? So I hope you got a clear understanding on how to build a RAG application by using LangChain, right? So here we try to ask questions and then get the answers from the LLM, right? All right. Thank you.